Okay, so this is chapter 3, and the overview here is that we're looking at count data. And so in our, I guess, simplest form of two variables, because that's what we tend to be worrying about, we could ask various questions like does gender have anything to do with movie choice, something like that. So you see gender and movie choice would be our two variables that we want to check, and so we might do something like, okay, here's gender, we'll go with male female just to make things easier, and movie choice also just going with two things. So here's our movie choice, and maybe something like romantic and comedy. I don't know what you do about a romantic comedy, but at any rate, we've got romantic and comedy. And so a person might just go out there and ask, what do you favor? And they could ask a number of people, and well, they could find that 20 males preferred romantic movies, 30 females preferred romantic movies, and here, let's say a lot more liked comedies, so maybe 40 there and 60 here. Well, so if this is the kind of thing that happened, and so now we have, we can get totals for our rows and columns, 50 and 100. Here we have 60 and 90. And if we add those together either way, we get 150. So there were 150 participants in our study, and we found that on the whole, about 2 to 1, so 2 here to 1 there, liked the comedies over the romantic movies. And we also see that we happen to ask more females than males, so 90 females, 60 males. Now, as you look at this, the question we ask is, well, does the gender seem to matter? And if these were our data, or does the movie choice matter? You can think of it either way, but if these are our data, notice that if I were to ask, well, if I knew a person's gender, would that change what I think they would choose? And if we're going to go with these data, I don't care what reality is. If these are our data, then what we would go with is, well, actually no, because you see, as I look here, of the males, 40 chose comedy, 20 chose romantic movies. So twice as many males chose comedy over the romantic movies. And I'm not sure why that moves up and down sometimes. It's just a ghost or something. And then of the females, that was also the case. So you see, if I knew somebody was male before I knew their movie choice, well, I'd say, well, it looks like there's about a 2 to 1 chance that they're going to pick comedy. On the other hand, if you told me, oh, no, they're female, not male, I'm not going to change at all. I mean, this is sort of what we would call perfectly independent data, in that other than the sheer number 60 versus 90, these ratios are exactly the same. It's 2 here, 1 there, 2 here, 1 there, and at the end of the rows we see that it's also that 2 to 1. And so you see, if you were to tell me the gender of the person before you told me their movie choice, well, I would probably in both cases pick comedy, but it really wouldn't change my perceived guess as to what it ought to be because they look just the same. Now, on the other hand, if instead we had these data, so gender and movie, okay, so again, romantic, comedy, male, female. But suppose our data in this case were something more like 20 male and chose romantic, and then 40 chose comedy. But then just the opposite here, say 40 female chose romantic and 20 chose the comedy. And we can still add up here. We see there's 60 and 60 and 60, and this time we only ask, I guess, 120 people. But now all of a sudden, if these are my data and you tell me the gender of the person is male, I'm going to pick comedy as my guess because it was 2-to-1 comedy over romantic. But if you told me the person was female, then all of a sudden I want something different. I'm gonna choose romantic movies over comedies because there the females were choosing the romantic movies 2-to-1 over the comedies. So all of a sudden, by you telling me the person's gender, that is going to change my guess. You know, overall, if I don't know the person's gender, I could look here and say, oh, it's about 50-50, right? Actually, 60-60. But about 50-50, same chance as either. But then all of a sudden, if you tell me the person's gender, I'm going to have a better chance of guessing right if I guess comedy if you told me the person was male, or romantic if you told me the person was female. And so you see, all of a sudden, gender matters in terms of movie choice. Back here, gender didn't matter. But here, if these were my data, gender does matter. Now, does it matter enough that I think these surveys that I did, you know, so I just went out, I asked 120 people, 60 of whom were male, 60 of whom female, and I got these numbers. Well, the question we have is, well, could that have actually been due to chance? You know, so for instance, you know, suppose this up here was actually what was going on. How likely is it that I could have gotten these data? And that's not exactly how we're going to answer this question, but that's the idea. Is we want to know, okay, you know, obviously as I look at these particular data here, it matters whether I am asking a male or a female. However, the question always comes back to, well, yeah, these particular data, literally speaking, we can see it matters, but at what point do I decide that there really is a difference, or in other words, there is a dependency, it does matter, or it was just by chance? And so by that, I mean, you know, let's look at maybe 3 of these. And, you know, so here are 3 possible datas again: male, female, romantic comedy, male, female, romantic comedy, male, female, romantic comedy, and we'll do the 60 of each male and female every time. So, you know, we're going to end up with 60 each time here. Oops. 60. Okay, 60. But you see, you know, if so up there I had the 40 and 20. Well, let's make it even more exaggerated. Maybe it's 50 and 10 and 10 and 50. Then I look at that and I say, oh yeah, that, I don't think I need anything like statistics or something like that to tell me obviously there is a difference between male female. Or I could say there's a difference between romantic movie, comedy movie as far as picking a gender. But usually I would say, well, tell me the person's gender, and I'll tell you what they like. Well, I could change the question and say, oh, the person said they liked romantic movies, and I guess from this data, I'd choose male. I'd say, oh, I think it's male, and if they like comedy, I think it's female. But so that seems quite obvious. But on the other hand, we had the 40-20 up there. So let's go with 35 and 25 and 25 and 35. And see, now it's becoming not so clear. Is it really there's a difference between male and female, or should these be about 30 each, and we just happened to take a sample that was a little different? So again, looking back at Module 1, we know that we can pull from the same population each time, but get very different answers. And so that could be what's going on here. And then, we get to something like, well, what if it's 31 and 29 and 29 and 31? Well, that, I would look at that and I would say, oh, this one is definitely not convincing to me. I think there's a very good chance that these could have been 30, 30, 30, 30 as far as what the underlying population is that it doesn't matter. Males and females like romantic movies and comedies exactly the same. Here, I don't know. I'm not so sure. This is where statistics can help us a lot, because it may be I look at this and I say, oh, well, definitely there's a difference in males and females. You look at it and you say, well, I'm not so sure. And, and then we get to something like this and there's probably no doubt among any of us that, yes, that would be telling us there's a difference. But that's where the statistics comes in, and that's what we'll be looking at really the rest of the course. We just start with these count data where I have these two categorical variables, so male, female, those are categories. Romantic and comedy movies, those are categories. So each of my variables is categorical, and typically the way we keep track of such things is then we just count, and we end up with tables like these. And so what we want to do is look at some statistics that allows us to analyze count data such as this and decide, if we see any data in particular, stuff like this, do we think it's independent? In other words, independent, there we go. In other words, it doesn't matter what row or column I'm in. I really should guess the same. Now, again, you look at that and literally speaking, no, I shouldn't, but it could be. The real question is, well, could this have come from an independent population where the gender did not matter? Or did it come from a dependent population where the gender does matter in this case? So that's our big question, is we want to know independent or dependent. And here's a pretty obvious case of dependent, whereas our first case was actually a perfect case of independent, because definitely there is no difference between these two columns as far as proportions go, or the chance of being in any one of these blocks compared to the overall sample. Okay, so that's what we're doing in a big picture sort of thing with these variables. And next we'll kind of look at two chi-square ideas as to what's going on there. So we'll finish this.